So hi, I am Nikhil and I built a distributed benchmarking platform for matching engines. The idea is simple. You upload your matching engine, the platform builds it, puts it on its own isolated machine, throws a tons of realistic order flow at it, then replace every single order through a reference engine to check if your trades are correct or not. And it measures how fast you perform this under the load. And then it scores you and puts you on a leaderboard. So you can think of it as like code forces, but for matching engines. So at high level, there's a web tier where contestants interact. A platform core with Redis as control plane and Kafka as a data plane. The per contestant workers that actually do the testing and the cloud infra underneath on GKE, Google Kubernetes Engine. So now let me show you the whole thing running. So So before I submit anything, let me quickly show you what a submission actually looks like. So contestant has to follow specific contract. The matching engine needs to expose two things. The first thing is a health endpoint. So the platform knows when the contestant's system is ready, and a WebSocket endpoint that accepts three types of messages: new order, cancel order, and modify order. So and every response from the engine uses the same shape, one JSON envelope for everything. So whether your order is rested in the book, got filled, got partially filled, or got rejected, same shape. It carries the outcome, the sequence number, the list of trades, and if any or if any and an error field. So the contestant packages their engine source plus a Docker file into a zip, and that's what they upload. So let me show you what the contestant zip file looks like. So basically, the contestants has to upload a zip file, and within a zip file, they should have a Docker file which we use to build images and the source code. And so now I will upload a sample submission. Okay. Hmm. So now let's start by submitting uh, my own matching engine, which I use to make the validator. So T late too much. So now I will use my own matching engine and then um, click on submit. So now, so now when I click on submit, the front end gets a temporary upload URL from the backend, and my browser uploads the zip straight to the GCS bucket. It doesn't go through the backend at all, and that's a small decision, but it changes and helps backend stay light and can handle many users at a time. So the so now so now you can see the image is uploaded, and backend just pushes this small job record into the Redis queue, and that's it. And the orchestrator takes things from there on. So now on the right side, I will just uh, hook into my Kubernetes pod. So now on the right side, as you can see, there's uh, the orchestrator has uploaded the image, the build image, and now it is starting to build a Docker image. And on this right side, as you can see, containers have been created. So now the status is building, and we have to wait for some time now. So till then, as you can see, the containers is the orchestrator is creating namespaces for this for the contestants, and Kaniko is building the image from the Docker file. So Kaniko is important because it builds inside a regular low privileged pod, no Docker daemon needed. So even if someone uploads a hostile Docker file, they can't break out. So now as you can see, the pods are created and the container is being created. So now we move to the pre-checks phase. In this, the platform sends about 30 known orders with known answers. And if your engine gets this wrong, the run stops here with score of a 0. So no point stress testing the engine that can't match basic orders correctly. And now the status is changed to testing. So now here you can see the we are using a showcase stress config, and I will explain about that in some time. So now as you can see, uh, the pods have started, and they are sending orders to the contestants system. So here it is really important to understand the configs, this build book, what is this build book, and what we are doing. So basically the first phase is build book. It only places resting orders, so they are just going to fill up in the book and set. They are not going to cross each other. And then there's a light mixed phase, in which this is a gentle phase, in which we send a realistic mix of new orders, cancel orders, modifies. So it gives us a clean baseline to compare everything else against. And then there's a heavy mix phase. In this, it is similar to light mix, but it is 10x the volume. We are increasing the number of orders in this phase. And then there's a cancel phase, in which we around 80% of the orders are cancellation orders. And then there's a matching spike phase, in which around 70% of the orders we send are aggressive orders, which will cross the best ask, best bid. And then finally the recovery phase. This is like this is like back to gentle baseline, to see if the engine's latency returns to normal after being hammered. And all of this phases are configurable. So the volumes, the ratios, even the number of orders that you are sending right now, you can configure them to check how your engine performs under different load. So as you can see, the pod one, it sends around total 260,000 orders. And similarly pod one sends 260,000 orders. Pod two sends 130,000 orders. So based on your configuration, it will send that many number of orders. And as you can see, as phase changes, there are some the throughput drops, the latency increases. As you can see, the latency increased a lot, and then again the throughput increases, the latency decreases. And and this happens, and this is what our bot plate is to check. When How does a contestant system perform when the order book's depth is when the order book's depth is a lot, and how it performs when the phase changes and all. So now as you can see, some of the bots have completed uh, their phases, and now other bots are completing their their own phase. So here you can see the total number of orders that has been sent, and here you can see the total number of trades that have happened. Trades means the orders that crossed the best ask and best bid sides. So as you can see, for different phases, the latency, the throughput changes, and that's what we want to measure under under stress, or under when bot fleet sends lots of orders. How does the system perform? And now, as you can see, the current phase is recovery. In this one, as I said, this is like this returns to gentle baselines. We send normal orders and at reduced rate. One thing I did that's important, I correct for something called coordinated omission. Basically, if engine stalls for a second, a nerve measurement would miss all the orders that should have been sent during that stall. They just never get recorded. So the P99 looks good, but it's a lie. And I measure from when each order has scheduled to be sent based on the target rate, not when it was actually sent. That way, a once again freeze shows up as roughly 99 slow samples instead of one. And now the status has changed to validating. And as you can see, the now the bots are done. The validator started, and what it does, it reads back it reads back the entire run from Kafka and replace every single order through the same matching code, or that my reference engine uses. And it's not sampling, it replaces all of it, and it compares trade by trade, the outcome, the number of trades for each trade, the price, the quantity, and the actual order IDs of the buyer and seller. And the last check is the buyer and seller IDs. This is a deep one. Two engines could report a trade at the same price and quantity, but match against different resting orders, and that might be a time priority violation. You can catch it by checking which orders actually traded. You can only actually catch that by checking which orders actually traded. And currently it shows correctness as 0 point 0.00. The reason is because the latency is high for the current matching engine. And to measure the final score, we use the targeted latency and the current latency we have, and then divide them and multiply them by the correctness score. The correctness score is 100%, but the latency is very high, and our targeted latency is around 10 milliseconds, 5 milliseconds, and based on that it shows the final score. And now I will show you multiple submissions. So there could be, I will show you multiple submissions. So now I'm using LiquidBook matching engine as well. It's a faster one, and in this one I made some changes such that it can use it uses the same contract as I'm using in the current one, so that bots can send request, and it is much more faster than my own matching engine. So now I'm just going to use this. I'm going to change this. This is the faster one, but it has some violations. So I will submit this. And now again I'm going to submit a second one, the one team lit. This one, in this one I am going to submit the one which is slower than the violations one. And now as you can see, the position in queue, it is like currently been queued, it is currently 0. It means that yeah, the numbers are messed up a bit, but yeah, currently it is in queue at first position, at the first position. I can submit another one in which I can just show team change. Then I can submit my own matching engine again. And as you can see, it's in position 1. It's at position 1 in queue. It means 2. The numbers are missed. And currently my old matching engine last kit is currently building the Docker image. And that's all I have.